Well, hello guys. It is actually Christmas Eve right now, but I thought I would do a different kind of video than the ones I've done. Stupid phone. No dirt biking or audio. Today is gonna be about electronics. So I wanted to show you what I have been working on over the last semester at school, and I thought I would show it off. So it's basically like a little mini Game Boy that I've made myself. It uses the MSP430 microprocessor, and that is at I'll tell you the details later. I'll show you. I'll just jump in. It can run off a 9-volt battery. I don't have any 9-volt batteries right now. And you can see it clearing the screen. Right now I've programmed for Skeet, a nice little retro version. Some nice 16-bit values in there. So I come down, you can see here, if I hit the button on the joystick, it'll change the difficulty. And then we can push and start. One button's to shoot, the other one's to pause. And if I can hit 5 right now, then I win. Oh gosh. And yeah, see, I won. Lots of fun. And if I lose, like, if I miss one more, then boom, I lose. Let me zoom out for you. So yeah, that's the game, and it's been a lot of hard work to get to this point, and it's been a lot of fun too, a lot of learning. But we'll go into a little bit deeper here. Alright guys, so we got the pins pulled off from the in-circuit programming just for the power. Over here we have a 9-volt battery tray for if you want to do it from a 9-volt battery, in case you wanted to make it mobile. I don't have a 9-volt battery right now, so that's why I had to do it off of these pins. But down here we got the, don't get my whole hand in there, we got the voltage regulator, which can take a 7 volts up to 12 volts input and output a nice steady 3.3 volts for the MSP430. We also have a joystick for 2 analog inputs and a button. Then over here we have 2 other buttons. We have SRAM, 32 kilobytes of RAM for external stuff, and then we also have a on-off switch. Then of course we got some capacitors for debouncing, and we have 4 resistors, 3 of which are for the 3 buttons, and then the other one is to pull up the reset pin. And then of course right in the middle of the board we have the huge thin film transistor LCD. It's a 240 by 320 LCD with 16-bit colors, which has been really fun. And since we don't have color on, or we don't have any power, I can just sit there and pull off the LCD. It's by Adafruit. It's actually been a lot of fun to play with. It uses SPI communication. We can have a SD card, but I didn't use the SD card in my board at all. But yeah, it's a lot of fun. And then down here we just have a nice 10-socket, 10-pin socket. Yeah. And then we also, right here in the middle of the board, we have the driving force, the MSP430. And I'm going to go into each of the different things a little more closer. Alright guys, just off the bat, I just thought I'd point out a couple design flaws I've had. So this is actually the first PCB I designed myself. And one of them you can see right down here. I thought the button was going to be right here, but actually the button was over here. How I fixed it is I just, drilled out a couple traces after the fact and cut them with one of the bits, and then just did a little jumper over there. It's not pretty, and my soldering's not that pretty either, but hey, it works. Another design flaw that I just found out today actually is that the on-off switch I accidentally put after the voltage regulator, which means whenever you have a 9-volt battery plugged in, it's going to have the voltage regulator on and drain a little bit of current. or a little bit of power, and so eventually your 9-volt battery will be dead, like the one I pulled out. So that's two design flaws that I kind of overlooked, which if I redesigned this, or if I reprinted it, I'd fix those too. But other than that, everything seems to be working in great condition. And yeah, we can just start jumping into the parts. So we just, over here we have a standard 9-volt battery tray, or I don't know if it's standard, but 9-volt battery tray. Just got some screws holding it in here and here and here. We got the two traces for the inputs. The wire is just folded underneath there. You can see the two traces come down to the voltage. The voltage regulator, and again, ignore my soldering. It's been quite a while since I've soldered, and even that I haven't soldered that much. But yeah, so we have the battery tray that goes over to the voltage regulator, and then that comes over to the switch. The pins for the in-circuit programming actually are behind the switch, so the switch doesn't matter if it's on or off when you have it connected to your launch pad, which you can see I have the wires just coming off my launch pad like that. But yeah, so from there we have the two buttons that we can go into. We got button 1 and button 2. In each of those, they have a pull-up resistor. I think it's resistor 1 and resistor 2. And they're pulled up to VCC, and then when you push the button, it grounds it out to ground. And then we have two of the capacitors are for these two buttons, and the other capacitor is for the button on the joystick, which I can pull over here, and yeah, right there. It's the same for the joystick, so one of the resistors for the joysticks too. So we have 3 capacitors, 4 resistors, and then like I said earlier, one of them is for the reset. We can go over to the joystick now, and for the joystick we of course have one potentiometer sitting here. We have the other potentiometer, and so you can see these are the 4 huge studs to hold it in. And I have all those grounded out, so you can see the trace coming over here to ground that out, and over here to ground that out. And then right here you can see that's the trace for power. And then in the middle is the 2 traces that go to the MSP430 for the input. And then doesn't look the best, but up here, yeah, we have the jumper for the button, which you can see. You can see I jumped it there, and then the trace right there is grounded out. Which I also just pulled solder over here to ground out the pin, the actual pin on the button. From there, we could go to the SRAM. So we have the SRAM over here. Nice little 8 pins. You can see on the back we have 3 of them are pulled to VCC, and a couple are pulled down to ground. And yeah. What next? Kind of flying through this. You got the MSP430, of course that's the really big one. That's where of course we have a lot of the traces coming from. So designing that, I've kind of wanted to put it right in the middle of the board. But it is a nice little 8-bit processor running at, well, microcontroller, if you want to say. It's running at 16 megahertz right now. I know, a whopping 16 megahertz, and it it actually does the job pretty well. I did run out of code size, or more like variables, because I had too many variables. I was getting close to too many variables on my program to do for it, because started breaking the program for my Skeet. But other than that, it runs pretty fast, and it's been a lot of fun. It does use SPI communication to communicate with both the SRAM and the LCD and whatnot, and then it has a bunch of different really cool features on it, different timers and whatnot, an analog to digital converter which we use for the joystick, which is a lot of fun, and it's been a lot of fun to learn how to program for it. But you can see here that I have these jumpers on the board. I wanted to use a single-sided board so that on the silk screen I could make it look all nice and professional. But in order to do that, there was a couple problems. The resistor for the button I wanted to have over here in its nice little array going on, and then I didn't really need, oh, and also the capacitor. So those were a couple traces that were really hard to get all the way from this side of the board to this side. So we do have, I think it was 6 jumpers. One of them is hiding underneath the battery tray over here. 2, 3, 4, 5, and 6. But I have those hidden behind the LCD, and I gave the LCD the socket so that I could pull it off and use it for other projects. And you see behind the LCD I had enough space to mount the MSP430, and the mounting hardware right here, it's not the best, and I'll probably make that a little bit better going later on, but for right now it works. And it just pulls off like that. It's a lot of fun. What else? I don't know, I'll probably think of something. Alright guys, well, I thought I would give you a nice little demo of programming with the in-circuit programming pins. So we just have a ground here, and then we also have our VCC, which here I'll unplug the MSP430, the launch pad at least. So you got the VCC, and then we have a reset, which is again pulled high from that resistor, and we also have a test, or maybe it's test and then reset, but yeah. So just those 4 pins are easy, and then on the launch pad you see here, all you have to do is take your little jumpers from the RX and RXD and TXD, and do them this way instead of that way. But other than that, just have the ground, the volts, the reset, and the test, or the test and the reset. And it's that simple. And so we sit here, I'll do it right here, and plug it in. And you can see MSP430 jumps to life. And this is a really nice feature that I added to my board, because instead of having to pull out that 20-pin socket and possibly, you know, bending a bunch of different pins, you know, like, you could just leave it in and do these really easy connectors and program it while it's sitting in there. So if you're like working on a game, you could just, you know, load it up and then boom, 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 try out your new game, and it'll be pretty good. So I thought I'd just load up this program here. It's not going to completely work, and it's honestly a program I made a little while ago, so it's a little wanky, but other than that, it works out pretty good. It's probably just gonna print out a bunch of different stuff to the screen, and we'll see. You know, sorry, there's a hair there. A bunch of different things. So we've loaded up the program, and I just sit here and hit run. You can see it just cycles through, it draws circles, a bunch of squares, and then clears the screen. And if I wanted to stop that, and then I load up my game again, and we can sit here and boom, and it'll load up the game after a little bit, and we can push play once it finally loads. My computer's a little slow, but other than that. Oh, and another thing I wanted to add is that up here, in the silk screen, I put all the different pinouts that I have for the MSP430. That way, when you're programming for it, you can just easily, like, you know, see what pins on what, and know like what to check in the registries and whatnot for that. So that's one other useful thing I put into that. But you can see here we got my game again, and if I just push play, then we can sit there and play again. You know. And so worked out pretty good. I actually, in order to get this to get the rotation of the rectangle, I actually am saving all the signs, all the values of sine from 0 to 90 in two 8-bit registries, or not. Each, like for the sign of 1, I save it in 2 registries, and for the sign of 2, I save it into 2 registries on the SRAM. So that took a while to program, but you can see it works out pretty good. And yeah, so that's my board. Thought I would just show it off to you guys, see what you thought. You know, got a bunch of the cool little things on the silk screen there. Just trying to make it look all really professional, you know. Go in there, you can see ground, VCC, test and reset. You know, IC programming. Of course, got all the Adafruit stuff. You can see all the different pins on that. Got ground, volts in, data or control. We got reset. I forget exactly which that one's for. But then we got chip select, MOSI, MISO, or master out, slave in, and master in, slave out. The clock and the backlight. So yeah, it's a lot of work. Spent a lot of hours on this thing, but ultimately I think it came out pretty well. So let me know what you guys think, and hopefully I can start doing some more videos on kind of electronics kind of thing. I was hoping to use this later on for temperature kind of thing, temperature sensor for in cars. Like, well, of course, audio is one of my other big hobbies. So having a temperature sensor where for a couple different sensors, it'll have Celsius and Fahrenheit, and then down here it'll have a graph of what the temperature is done for a bit. And so that'll be pretty nice. You know, I'll have one connected to my amp or to the back of my sub for the magnet, and it'll be cool to see, like, you know, how hot things get and just be able to monitor my system. But just a couple of ideas I have for the future for the MSP430, and it's been a lot of fun learning how to program for it. And let me know what you guys think.